This is a slightly more complicated example using arrays, and it shows how to use them to calculate factorials. Now, if you don't know what a factorial is, it's a mathematical function, and the usual notation is to use the exclamation sign. So n factorial, the factorial of n, is n times n minus 1 times n minus 2 all the way up to times 1. So for example, 3 factorial is 3 times 2 times 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24. They grow very quickly. There's an alternative definition of a factorial, which is basically it's equal to itself times n minus 1 factorial. And it's sort of that property we're using here, because we're going to be creating factorials in an array. And the main reason for doing this is because we have to calculate them. We don't know them beforehand. In the examples with the shapes, we knew the data beforehand. Here we don't. So we're somehow going to have to create an empty array and then stick data in it. So that's the first part of this here, is how do you create an empty array? And you do it like this. Okay, so we've created here an integer array, so we've got int, we've got our square brackets, and we've got our name, we're calling it factorials, and we use this syntax here. We use the new keyword, we use int again, and then in the square brackets here we put the size of the array we want. Now, one of the critical things about arrays is that once you've created one, you can't just say, oh, and can we add a few more bits onto that, please? You have to create yourself a new one, copy any data across, and it does start to get really rather difficult. So generally speaking, you've got to know how big you want it to start with. In this case, we're going to say 5. Now, I'm going to skip over this first loop for now because it's slightly more complicated, and I'm going to look at the simpler one. This is something we've seen before, really. This basically is going to print out our factorial array once it's created. So we have our integer I starting at 0. We keep going as long as I is less than the length of the array, and we add 1 each time around the loop. And we're going to print out the value of I, so this will print out 0, 1, 2, 3, 4, and so on. Then a colon and a space, and then we're going to print out the element of the array that contains the factorial we're looking for, okay, which we've calculated in this piece of code here. Now this is a little bit more tricky and shows some of the more tricky things you can do. Now the thing about this is we're going to be using this property here, essentially. This is what's called a recursive definition. You can write some quite interesting programs based on this, but we're not going to get to that kind of thing in this module. But we're going to do something slightly simpler based on the same idea. The idea is that we're going to calculate n minus 1 factorial, starting for n equals 0, and then we're going to use that to calculate n factorial. Now, turns out that by definition 0 factorial is equal to 1, so that's a very easy thing to do. We can just simply stick into the 0th element of our array factorials the value 1. Then to calculate the next value, then we need to multiply this by, again it turns out 1, to calculate 1 factorial, because slightly confusingly 1 factorial is also 1. So that's what this loop here is going to do. Okay. Now, one thing that's slightly different is we're starting our counter from 1, and I'll explain why in a minute. But as before, we're using factorials.length to control how many times you go around, and we're using I++ to add 1 to the loop each time. Now this is the key line. This says the ith factorial is equal to I times the factorial of I minus 1. We've already calculated, because we're going to be starting from 0, 1, 2, 3, 4. So we'll have already calculated our factorial I minus 1. The very first one is factorial 0, which we've set to be equal to 1. So that we're then going to multiply that by I to calculate factorials I. So if we talk this through, we're going to start off with I equal 1. That means we're going to say, well, factorials 1 is equal to 1 times factorial 0. We've already said factorial 0 is 1, so this is going to be 1 times 1. So factorials 1 is going to be 1 again. Then we're going to make I 2. So we're then going to say factorials 2 is equal to 2 times factorials 1. Well, factorials 1 is 1, so it's 2 times 1, which is 2. Then we're going to do factorials 3. Factorials 3 is equal to 3 times factorials 2. Well, factorials 2 is 2, so that's 3 times 2 is 6, and so on. Now maybe now it's a bit more obvious why we started the loop at 1, because if we'd started this at 0, the very first time we go around this loop we're going to be asking for Factorial 0 equals 0 times factorials 0 minus 1. Well, 0 minus 1, array element 0 minus 1 does not exist. So the array would crash at this point. So this is a common example of something that we have to do, where we have to do what we would call the base case, the very first thing we have to do kind of separately, and then the steps from then on continue based upon the fact that we've already manually, if you like, or separately calculated the first value. I'm going to run this. I've already compiled it, and as you can see, it does print out factorial 0, 1, factorial 1, 1, 2 is 2, 3 is 6, and 4 is 24. Now, although we can't change this while the program is running, we can change it now and recompile it. So I could change it to say 8, and I could save it, and I could run it, and now we get up to factorial 7, which is 5040. As you can see, these things grow very quickly.